Yes, yes. Good afternoon. Welcome to Embedded System class. Few more friends has to join. Ask them to join soon. Okay. Uh, we are towards ending of our CA portion. Few more, few more important topics need to cover. Okay. So I'm not going to hold for your friends to join. Let them watch the recorded video. Okay, let me start with the on time. So today's agenda was actually I told you people to read exception in detail by your own. We hope you couldn't find time to read, so therefore let me finish that exception as a first part. The second one, data path organization. Third one, byte ordering. Okay, so within half an hour, or it will, if possible, I will cover two portions. Okay, ARM exception and data path. Then we have one more fantastic feature, very well known to you, is the pipeline. Okay, and that portion will be continued by the Dr. Sundar Ganesh sir. Okay, so up to half of the session I will handle the class. Okay, so without making much time, let me project the screen to you. So ARM exceptions. Okay, so you know the type of ARM exceptions. So ARM exceptions happens in three major conditions. Can anyone tell me what are the three major situations said by the ARM people? What are the three? Any idea? I think your chat box also enabled. Okay, today let me move. Whoever want to interact, please interact via your mic. Okay, so we need to cover a little portion. Okay, scheduled portion. So let me, without making much time, let me show those things. Interrupt, trap, supervisor calls. Okay, very good, Rishwan and Sabrishiti. Interrupt, trap, and supervisor calls. And what are the importance of that you know well. Then it happens in direct effect, side effect, and generated externally. Okay, so generated externally is the fantastic one. Whenever you do some project, definitely you can play with this external exceptions. That is where interrupts. There are two type of interrupts available in that. The external normal interrupt and fast interrupt. Along with that, you have one more thing is reset. Okay, so reset is a usual one whenever your system getting hang, or whenever you are interested to switch back to the origin and you want to continue your system to work, you will do reset. Okay, so those are all. See, already we know these terms, but here it is categorized in some other new name. That's all. No need to worry about it. Okay, so whatever we are studying is a known factor, but comes under some special category. So that is the exception. Okay, yes. The priority table is very important. So how to read the table? The first column is the exception name. Second column is the priority level. The third and fourth are very important. Here one represents, one means whenever I do reset routine, the reset exception, at the time my normal interrupt and fast interrupt will get disabled. Here one represents disable. Hyphen represent what? You can't disable the fast interrupt during data abort. That means data abort, while you execute the data abort, at the time if immediately fast interrupt comes, even you can pause your data abort routine and you can switch it to the fast interrupt. That is the idea behind this. Okay. Then one more thing is the software interrupt and undefined. These two are having same priority level. So these things you should remember. And one more thing, vector address. It's very important, sir. As a programmer, you must know where I need to write the coding. for the particular subroutine. Say example, data about fast interrupt IRQ. I need to write. Please go through here, go through the vector address. First one, the SVC. See, these are all based on the mode. Whenever you reset, it would come to this mode, supervisory mode. Then the vector address is this. That means whenever you do reset, your coding starts from 00. Whenever undefined instruction, that means the last table. If the particular interrupt comes, your system goes to this vector address. Whatever the decision you need to make in the particular exception, you need to write a coding in the starting address of 0004. Similarly, for software interrupt, prefetch abort, data abort, normal interrupt, each and every one have a different address location. Here the beauty is that all things are incremented by 4. Am I correct, sir? 4, 8. If you increment 8 by 4, how much will get? 12. That is equal to C. Am I correct? If you increment C 4 times, how much you will get? 10. If you increment 10, usually you need to get a 14. Am I correct? But here it is not 14. Here it is 18. So, and one more thing you observe, fast interrupt request vector address is 0001C. What is the advantage of having fast interrupt vector address at the last in the table? What is the advantage? Actually, the fast interrupt is then only the emergency one. So whatever the very higher priority hardware thing, we will write it in the fast interrupt. Say example, fire alarm. Okay, or any major things you need to sense, the temperature sensor of any one thing you need to sense. Accordingly, you need to take some decision use. So higher priority peripherals, we will connect it in the FIQ. Okay, fast interrupt request. So what will happen? The programmer can start write the subroutine for the particular interrupt from the starting line of 1C. As in continuously in the interrupt line, coding you can write it. But if you observe here, you have only 4 locations to write your reset program. Again, undefined program, you have only 4 lines to write. Is it possible to write all the subroutine program with the 4 line? Not at all possible. That means what? Whenever the interrupt occurs, you will enter here. Here you will give some instruction. Say example, the well-known instruction, jump. Call instruction. Am I correct? If you give us some address with the call, it will switch to some other address location. There you may have your original program for your undefined instruction. Similarly, for the software interrupt, you have only 4 lines to write. So within the 4 line, most of the time not possible to write the entire code. Again, address location coding. Whenever the particular interrupt comes, you will get it to this vector address. There you will give some indication in the line. Thereby, it moves to the subroutine program where you have written. There is no limitation. Memory is the limitation. You can write n number of lines. But always the subroutine codings are minimal in size. It won't execute more than even a minute. Okay, most of the time it will be in milliseconds only. Okay, so subroutine coding length always will be very less. But in fast interrupt, there is an advantage already by the register wise. For the fast interrupt, we have more bank registers. Thereby, you no need to make a copy of much registers while you move from user mode to the fast interrupt. Okay, that and all we will see. In detailed way. Don't worry. Okay, why the fast interrupt is consuming less time to execute the particular interrupt, we will see. For first advantage, it has more number of bank registers. Okay, and the second one, the vector address location. That is this address location where it is address location here. Wait a minute. Let me show you here. Address location. So from this address location, you can start write your whole program. So switching from this address location to some other location may consume some time that you can avoid. Please note down this table as well as the vector address. So whenever you practice with the code, then only you can realize what we have discussed now. Okay, then we will continue from there. Vector table you understood. Everyone is incremented by 4, but for fast interrupt can start immediately. Please note down this keyword. Why you can start immediately? From the 1C itself, you can start writing your fast interrupt coding. So that is the advantage of your FIQ interrupt. For other routines, you will give some direction. From there, we will move and we will start execute. Okay, this is a fantastic feature. Vector tables are very, very important. All the time, it won't go to the same location. Based on the exception, it will reach the particular address location. There, it will read the corresponding coding. From there, it will move. Okay, I hope is it clear to everyone. Any doubt in this? Any doubt in this vector table? Any doubt in this vector table, sir? I hope no. Okay, now we will move to interrupt handling. What is the interrupt handling? Very simple, sir. Please go through the top blocks, main program, ISR, and main program. That means what? Usually we will do main program. When our interrupt comes, we need to jump from main program to the ISR. Then after finishing the ISR, where we will move, again we will jump to the main program. Am I correct, sir? Am I correct? This is the flow whenever interrupt occurs. But what are all things I need to do before switching from main program to the ISR? That is called interrupts handling. Please note down how to handle the interrupt. We need some set of procedures we need to follow while handle the interrupt. What are all things in detail we need to see? First, main program has a program running for unnitric. Okay, CPU resources use பண்ணுது. என்ன resource use பண்ணுது? CPU registers, and register will have some content of main program. இப்போ ரன் ஆகும்போது இதெல்லாம் வச்சிருக்குது. ஓகேவா? Then program execution may affect the flag register content. Whenever you are executing the main program, that time register is occupied, and what? Your flag register is also getting updated while you execute the main program. Am I correct? And program counter points the address of the next instruction need to be fetched. These are all the flow. If there is an interrupt, can anyone tell me what we need to do from the next line? Now interrupt occurred. What we need to do? Can anyone unmute and tell? See, main program run ஆகுது. Register use பண்ணிட்டு இருக்குது. Flag use பண்ணிருக்குது. Program counter points the address of the next instruction to be fetched. Now interrupt arrived. What we need to do? Is it simply we will keep everything, don't care, and immediately we will jump it back to the ISR? Hello? Else we need to save something before we get into the ISR. Any idea from your side? Dear students, please. Any idea? கொஞ்சம் interrupt பண்ணலாம். இந்த flow புரியுதா? main program run ஆகுது. Interrupt will run. Service routine will run. Okay, see, interrupt will run. Okay, we need to run the interrupt. Before getting into the interrupt, do we need to do anything here? See, very simple. I gave you one example. Whenever you are reading something, this is the famous example given in a textbook. Whenever you are reading some textbook, if mom calls and gives some work, what you will do? Whether you will throw your book and you will go store the old value. You tell me in the example of the book reading, you will have some bookmark, you will keep some pencil inside or pen inside, and you will close the book and you will go. After doing everything, you will come from where you will start? From your bookmark. Am I correct? At the same time, whatever you studied in the previous time, you should have the same values again. Then only you can continue and read the story. See, in between book படிக்கும்போது அம்மாட்ட போயிட்டு வந்தனால உனக்கு முன்னாடி இருந்த கேரக்டர் அந்த ஸ்டோரியில இருந்தவங்க எல்லாம் மறந்துருந்ததுன்னா whether the remaining pages will be understandable by you. ஒரு பாதி புக் படிக்கிறோம், திடீர்னு யாரோ ஒருத்தவங்க நம்ம கூப்பிடுறாங்க. Whether you will forget everything, is it you will start read from the beginning, or you will remember something with that idea you will continue. Anyone unmute and tell. Anyone unmute. அந்த ஸ்டோரி படிச்சுட்டு இருக்காங்கன்னா ஸ்டோரிக்கு இடையில ஒருத்தவங்க வந்துட்டாங்க, அது இந்த கேரக்டர் எல்லாம் மறந்துடுவியா? Am I audible on the other side, dear students? Hello? எல்லாரும் நல்ல ரசம் ரசம் சாம்பார். வசந்த், am I audible? வசந்த், வசந்த், சந்தோஷ், அஜய் குமார், அரவிந்த், கண்ணா நான் பேச கேக்குதாடா? பண்ணியே சிலபஸ் முடிக்க முடியல எனக்கு. சரி சொல்லு, நீ புக்கு படிச்சுட்டு இருக்கிற, அம்மா வராங்க, புக்கை மூடி வச்சுட்டு போற, திரும்பி வரும்போது உனக்கு ஃபர்ஸ்ட் பேஜ் இருந்ததெல்லாம் மறந்துருக்குமா, இல்ல உன் மைண்ட்ல ஸ்டோர் ஆயிருக்குமா? யாரு வில்லன் யாரு ஹீரோ இருக்குமா இருக்காது? ஹலோ,
இருக்கும் சார்.
இருக்கும். Without having the past memory, it is not possible to continue the story. Am I correct? அதுக்கே அவ்வளவு இருக்கு அப்படின்னா, you are doing some tedious process with the help of your microprocessor or a controller. At the time, think about the previous value. So what we need to do? So whenever the interrupt occurs, ISR also have some program saved in a certain address. Okay, then it also need a CPU and register usage. And register will have some content in ISR. ISR may affect the flag register content. Am I correct? And after ISR is over, we need to come to the main memory. So, அப்ப என்ன சார் பண்றது? ISR program இந்த register may be use பண்ணலான்றாங்க. என்ன பண்ணணும்? So whenever you get into this, you need to do in between this. Before getting into the ISR, please note down. Please note down. Return address must be stored. Second one, register content must be stored. That means what are all the registers will get affect while you do the particular interrupt, those registers you need to take a backup. Flag register must be stored. How we are storing the flag register? Your CPSR content, we need to move it to where? Can anyone tell me? CPSR content have some flag values. Where we will move? Any idea? CPSR content? CPSR content la flag value irukku. We need to move it to CPSR content.
SPSR.
Yeah, very good. We need to move it to the SPSR, saved program status register. Okay, then context of the main program, whatever the context related to that, you need to save, then only you need to get into that. What is the new name you need to add? Context saving. Please note down. Please note down. Main program, context saving, then only you need to get into the ISR running. You remember, okay, now you are running the ISR. After running the ISR, what I need to do? Any idea, sir? After running the ISR, what we need to do? What we need to do? We need to revert back the value stored in the context saving. What it is called as context restoring. Once ISR is over, we need to return to main program. The saved context of main program is restored. The return address restored, register content restored, flag values restored. That means saved program status register to the current program status register, we will copy back. So this is a fantastic thing you need to remember. Please note down this flow: main program, context saving, ISR running, context restoring, then main program. Is it clear up to this? Is it clear up to this? நம்ம வந்து மைக்ரோ ப்ராசஸர்ல படிக்கும்போது இந்த மூணு பிளாக் தான் படிச்சிருப்போம். Am I correct, sir? Main, ISR, then main program. But இங்க you have a few more things: context saving, context restoring. I hope it is clear to everyone. Okay, then context saving க்கு என்ன பண்ண போறோம் சார்? ஒண்ணுமே இல்லை. See, your main program 5000ல இருக்குது, ISR 9000ல இருக்குது. இப்போ என்ன ஆகுது? ஒரு interrupt வருது. If interrupt comes to the CPU, please observe, CPU The register values, whatever the register values you need to back up, we are storing into the stack. We are storing into the stack. Then flag registers need to be saved in the what? Here it is simply shown as a stack, but where we will store? We will store it in the SPSR. Then return address need to be saved. Return address need to be saved. Where the return address is available? Where the return address is available? Return address எங்க இருக்கணும்? Return address எங்க இருக்கணும்? நம்ம இப்ப படிச்சிருக்கோமே linked register. No, not in the stack. Not in the stack. Return address எங்க இருக்கும்? Registers படிச்சோமா? Link registers ஏதோ படிச்சோமா? There you need to keep your return address. Then program counter will reset the value to in the program counter தான் நம்ம திரும்ப வரணும். இப்போ 5500 execute பண்ணிட்டோம். Next வரணும்னா I need to come to the 5504 க்கு வரணும். அதை I need to store. Then only we will get into the ISR. It's very, very important. Please note down this flow. So now, we are jumping from here to here, but in between we are doing something. That means what? Interrupt arrived here, but after doing these many tasks only, we are getting into the interrupt. That means it will take some time delay. What is the time delay? It is called as a interrupt latency. Note down. Interrupt latency. What is interrupt latency? Consider it as a timeline. Consider it as a timeline. Main program, context saving, ISR, context storing, and the main program. At time 0, you are running main program. Say example, here the occurrence of the interrupt. Occurrence of the interrupt. If true interrupt happens at the same time, check the priority level. Based on the priority level, which one you need to address it. After finishing the higher priority, check again the second interrupt is present or not. If it present, go and finish that, then come to the main program. I hope it is clear. I hope it is clear. Okay. Then occurrence of interrupt inge vandiruchu. Appo enna pananum? I need to do a context saving. Then after that only we need to attempt the ISR to run. There is a huge time gap. There is a huge time gap. This time gap, this delay is called as interrupt latency. Note பண்ணி வச்சுக்கோ. What is interrupt latency? எப்ப interrupt வந்துச்சு நம்ம எப்ப சர்வீஸ் பண்ண ஸ்டார்ட் பண்றோம். Why there is a delay? Why there is a delay? The delay involves context saving. Is it clear, dear students? Is it clear, dear students? So that is regarding your interrupt latency. It is a very, very important phenomena. Many of the time they will ask what is interrupt latency. You are supposed to answer for this. Okay. Interrupt arrived here, but after context saving only we are able to enter into the ISR routine. Thereby there is a huge gap. That delay is called the interrupt latency. Okay. Then, so the priority level, sorry, here it should be 6. Undefined one thing is 7, it should be a 6. Okay. So FIQ has a low interrupt latency than IRQ. Why? Why, sir? Compare panni parunga. FIQ has a many bank registers than IRQ. அப்படின்னா என்ன அர்த்தம்? இந்த கான்டெஸ்ட் சேவிங் பண்ணும்போது number of registers backup பண்றது FIQ ல it is very less, but IRQ ல you need to take a more backup. Then vector address, please check the vector address. Immediately after the vector address of 001C, you can start write your FIQ code. Thereby it will consume less time than the IRQ. Thereby which interrupt you need to connect it in the FIQ and which interrupt you need to connect to the IRQ, the programmer and the hardware designer need to think and do it. Okay. Is it clear? Is it clear why the interrupt latency is less in the FIQ than IRQ? Because the bank register in FIQ is more. The second reason, the vector address is the advantage. After this vector address, you don't have any restriction. You can start write your entire code after this line. Is it okay? No need of branch. No need of branch instruction. You no need to branch to the different address location to run your code. And one more thing, has a higher priority. We have a higher priority. You no need to wait for other person to finish, then you need to come back. Say example, at a time you are getting IRQ interrupt and FIQ interrupt. Which one we will execute? Subversity asks the same question. No, if two interrupt comes in the same time, which one we will address? We will check for the priority. Which one is having higher priority? FIQ has higher priority. Lesser number means higher priority. 3 அதுதான் ஹையர்ல இருக்கு. அப்ப FIQ முடிக்கிற வரைக்கும் IRQ வெயிட் பண்ணணும். Again that will make a interrupt latency. Okay, I hope these 3 are the major reason why FIQ has a low interrupt latency. Okay, then these are all exception handling. So exception handling நம்ம இது வரைக்கும் பேசினதுதான். என்ன பண்ணணும்? மெயின் ப்ரோக்ராம் ரன் ஆகும், ISR இருக்கும், ஸ்டாக் இருக்கும். நம்ம என்னென்ன மூவ் பண்ணணும்? ஒரு எக்ஸெப்ஷன் வந்துருச்சு அப்படின்னா கான்டெக்ட் சேவ் பண்ணணும். சேவ் பண்ணிட்டு you need to start work. என்னென்ன கண்டென்ட்டை எங்கெங்க மூவ் பண்ணணும்? ஓகேவா? See, for example, you are in the user mode. You say example interrupt request வந்துருச்சு. அப்ப என்ன சார் பண்ணணும்? You will replace the existing register. Say example, normal interrupt வச்சுக்கோ. Normal interrupt na you will get only these 3 bank registers: R13, R14, SPSR. What about the remaining registers? R0 to R12. You need to take a backup. Am I correct? You need to take a backup. Am I correct? Then mode change ஆகும்போது நல்லா பாரு. Mode change ஆகும்போது நல்லா பாரு. Now in this mode, we replace the R13 and R14. R15 is the next instruction. எது நமக்கு fetch பண்ணி indicate பண்றது இங்க கொடுக்கும். The link register will hold. இது முடிச்சதுக்கு அப்புறம் நம்ம எங்க போகணும்ன்ற லிங்கை இங்க ஸ்டோர் பண்ணி வச்சிருக்கோம். R14. ஓகேவா? So R14 R13 வந்துருச்சு. Then the remaining registers நம்ம என்ன பண்ணிருக்கோம்? எல்லாமே நம்ம என்ன பண்ணணும்? தூக்கி பேக்கப் எடுத்து வைக்கணும். ஓகே, பேக்கப் எடுத்து வைக்கணும். After இதை பேக்கப் எடுத்து வைக்கணும். Then these registers only the new. Okay, then நம்ம இந்த மெயின் ப்ரோக்ராம்ல இருந்து இங்க மூவ் ஆகும்போது current program status register we need to move to the save program register. So இந்த process எல்லாம் பண்ணிட்டு we are getting into the interrupt. So அந்த interrupt run பண்றோம். So அந்த interrupt run பண்ணும்போது நல்லா பார்த்துக்கோங்க. main program, then we are getting into the main program last address எடுத்து நம்ம we are storing into the link register. First task. Second one CPSR copied into SPSR. Third one நல்லா பாத்துக்கோங்க. Third one என்ன பண்ணணும்? We need to disable the particular interrupt. நல்லா பாத்துக்கோ. Same interrupt again வரக்கூடாது. மேல பாரு 3 ன்னு போட்டுருக்காங்க. What it means? We need to disable the interrupt. Same interrupt again வரக்கூடாது. ஓகேவா? So we will disable the 3. Fourth one, use register need to be saved into the stack. Use register need to be stored into the stack. Then fifth one, we need to store the ISR starting address in the program counter. So aduthu program counter la potada ISR program run panna mudiyum. Is it clear? First step last enna instruction nam execute pannirukamo adukku adutha irukka address we need to store it in the link register. Then current program status register move to this SPSR. Then we will disable the interrupt. Then registers you need to take a backup. Then we need to move the ISR address into the program counter. Then we will start execute. Okay, return ஆகும்போது என்ன சார் பண்ணணும்? return ஆகும்போது SPSR ல இருக்கிற CPSR கொண்டு வந்து வைக்கணும். Then the link register value what we have already stored, that is your starting address. From there we need to start execute. Okay, so this is the regarding your exception. Interrupt வந்ததுக்கு அப்புறம் என்ன பண்ணணும்? interrupt முடியும் போது என்ன பண்ணணும்? ரெண்டுமே correlate பண்ணி ஒரு தடவை ரீட் பண்ணிக்கோ. Please take a screenshot of this one. Take a screenshot. Please say yes if you took. Yes. Okay. Then take the screenshot of this one. read it. Okay, any questions we will discuss hopefully in your offline class. Okay, so now sir will continue the new topic. Please note down. Okay, thank you very much.
Good afternoon. I'm Dr. C.S. Ganesh. Still, you are in online class for the last 1.5 years. I don't know. I see some of you came in last year. So, in the new topic, we are going to see is pipelining. So, before going into pipelining, so what is the need for pipelining? For example, if there is a place where they are giving um, கொரோனா நிவாரணம் கொடுக்குறாங்கன்னு வச்சுக்கோங்க. ஒரு ஆள் கொடுக்குறாரு, என்ன பண்ணுவாங்க மக்கள்? கும்பலாக போய் அங்கே நின்றுவாங்க. ஒரு ஆள் கொடுக்குறதா இருந்தால் எவ்வளோ நேரம் ஆகும்? How much time it takes? It takes nearly very long time. So அப்புறம் then they introduced the concept of parallel processing. So what is parallel processing means? ஒரே வேலையை same work done by two people. So, for example, there are 100 people who need help. If one person is doing the help, means remaining 99% have to wait. Then they introduce the concept of parallel processing. So, parallel processing means if 4 or 5 members are there doing the same help, means so the 100%, they are divided into 5 different groups, 20 groups. So the helping time is very much reduced. So even though in parallel processing, the time is reduced, but there is a problem of hardware. So 5 members are needed for the particular operation. Here also, when you go for the system, 5 different systems are required. So 5 similar systems are required. So the hardware dependency, it depends upon the hardware. So cost of the system will go high. Even though we are reducing the computational time, the cost of the system is going very high. So then they introduced the concept of pipelining. So what is pipelining means? Same 5 members, they are doing, each member will do a certain work in a process. For example, if it is a process, there are 5 different works. In parallel processing, if there are 5 different works, the same person has to do the 5 different works. In pipelining, so 5 different persons are assigned 5 different works. Single person will do a single work only. So he will do only one work. So after finishing the first process, he will send the material to the next process. So second person is doing the second process. So the first person is now free. So he will do the next job. So after processing second one, it will go to the third person. So the first person is, after finishing first job, we will take the second job. So after finishing second job, we will take the third job. So the time is very much reduced. And also, when you compare parallel processing, Here, the time is reduced nearly 200%. Same 5% if you used in parallel processing and same 5% if you used in pipelining means pipelining speed is very high when compared to the parallel processing. So in olden days, they are using the concept of parallel processing. Nowadays, all the microcontrollers and processors are used only pipeline. So you have already come across what is pipelining. So we will see. So it is an example related to education. So in our department itself, if you take, there are 3 classrooms or 6 classrooms. You take as a single classroom is available for a particular year, second year, third year, and fourth year. So in 2020, so here given an example. In 2020, first year you have joined, some group of people have joined. The second year, in 2021, they have moved to the second year. So they have fixed a class for second year. So in some colleges, they have fixed this is the classroom for this particular class. First year, this is the class. Second year, this is the class. Third year, this is the class. And final year, some classes. So those who joined in 2020 will move to the next class in 2021. Now the first class is free. That class is used for the current first year. Similarly, when you move to 2021 to 2022, they are moved to third year. Now, second year class is free. That new batch will go to from first year to second year will occupy the seats. And then the first year class is once again free. Okay, only 4 classes are enough for the entire department if there is a single class. In our college, it is 2 classes or 3 classes. If it is a single class, single section means 4 classes are enough. Here also you can do some parallel adjustment in the timetable such that you can use 3 classrooms for 4 years. It is also possible. You take one classroom is fixed for one section. So when the class is going on, all the 4 classrooms are available. All the 4 classes are going on in parallel. So it is not pipelining; it is a parallel processing. The pipelining concept is only introduced in the classrooms. The students from the first year, the next year they go to the another class. The first year class is free. So the new batch is coming into the first year. So after finishing second year, you go to the next class, that is third year class. Fourth year class, after finishing fourth year class, you will went out. This is the pipelining concept. They are coming in the first year class, moving to second year, third year, fourth year, and moving out. When the first batch move from first year to second year, next batch comes into first year. This is the pipelining concept. But actually, if you take as a whole, 4 years classrooms are going simultaneously means it's only parallel process. Okay. You should know the difference between pipelining and parallel process. So, what is the use of pipelining? So, pipelining is a process. So, in order to utilize the hardware resources effectively, and also we have to reduce the time. Main thing is we have to reduce the time, we have to reduce the cost, and we have to effectively utilize the hardware resources. So here how pipelining is done in a microcontroller or microprocessor. So what we are doing is we are writing a program. Program is a set of instructions. So we are writing a very big program. So if you take a single line, it is a single line of instructions. In earlier days, if you take Pascal programming or Fortran programming, so every line they are given a line number. Line number 1, line number 2, line number 3, and so on. Nowadays it is not that. Nowadays also if you compiling the program, so while compiling, if there is an error, it will tell you what is the line error. So where is the error? which line it is error. So even though it is a program, it is a combination of different lines of instruction. So it will take one line at a from the program. First, it will take the line from the memory. That is known as fetch process. So after taking the instruction, so we will take as a instruction. So after taking the instruction, it will check, it will decode. So what are the components in the instruction? So what is the process needed for that particular instruction? So you should know that is known as decoding process. So after knowing what are the process required, so it will execute the corresponding control signals and operations. So these are the three operations. First you have to take the instruction from the memory. Then you have to decode. Decode means you have to analyze the instruction and you have to generate the necessary control signals required for the operation. Finally, execute means so the operation is executed. So concurrent execution of instruction. So concurrent execution means simultaneous execution of instruction. So when you are doing a parallel processing or pipelining processing, so it will increase the speed of operation. So automatically speed will be improved. So if the speed is increased, time will be reduced. So minimum hardware is used. So it is a parallel operation. So there are different ARM processors. They have come from ARM 7, 9, 10, 11, and so on. So we are concentrating on the ARM 7 processors. So how the ARM 7 processors doing the pipeline? If we go for ARM 9, it will become 5-stage pipeline. In ARM 7, it is 3-stage pipeline. So what is 3-stage pipelining means? The entire process is divided into 3 categories. 3 processes. The big process is divided into 3 processes, 3 small processes. That is known as 3-stage pipelining. If we go for higher end processor, it goes more number of stage pipelining means the process is split into several small processes. 5-stage, 6-stage, 8-stage pipelining is also available. So in ARM 7, it is only 3-stage pipelining process. The sub-processor are fetch, decode, and execute. So fetch means taking the instruction from the memory. Decode means so it will analyze the instruction. What is the instruction required? So it will generate the necessary control signals as well as the required operations. So finally, it will execute. So there are 3 stages: fetch, decode, and execute. So what is the fetch operation? The instruction is fetched from memory and it is placed in the instruction pipeline. So you have seen that you have done the assembly language programming. So you have written some mnemonics. So there is mnemonics. So one instruction, one line of instruction we are calling as one instruction. So that one line instruction is taken from the memory and it is placed in the instruction pipeline. So we see the pipeline here back. Okay. This is the pipeline symbol. So first, this is the time period: T1, T2, T3, T4, T5, T6, T7, and T8. So this T1, T2, T3, we take one particular process for a particular one instruction. So for every instruction, these 3 operations are required. First, you have to take it from the memory, decode it, and execute. This is instruction 1, instruction 2, instruction 3. Okay, now see. So it will take from the memory and it will place in the instruction pipeline. So after placing in the pipeline, so it will decode and it will produce the necessary control signals for the particular instruction. So execute means, so it will create the channel. For example, I want to store the data from the accumulator to the memory, or I want to copy the data from one register to another. These are called process, and this will be happen in the execute cycle. So if there is no pipelining, this symbol shows that there is no pipelining. Only one hardware is available. Then you require for every instruction you need 3 stages: fetch, decode, execute. Similarly, for second instruction, fetch, decode, execute. Third instruction, fetch, decode, execute. For this every operation we are calling as a cycle. Fetch cycle, decode cycle, execute cycle. Combining this fetch, decode, execute, we are calling as instruction cycle. So instruction cycle consists of fetch cycle, decode cycle, and execute cycle. If there is no pipelining in a particular processor, for example, if you take 8085, there is no pipelining. So every instruction will be taken one by one, and for a particular 3 instruction, you will get 9 cycles for operation. Now that is a pipelining operation. So if we look at this T1, T2, T3 time period, T1 totally 9 cycles are required for 3 instructions. Same 3 instruction if there is a pipeline. This is known as 3-stage pipeline. Fetch, decode, and execute. So first clock cycle. So this particular column is only this is time period. So first column is time period. Here, so totally there are 3 cycles. So one process will do only the fetch cycle. Another process will do only the decode. Another one will decode only the execute. So first instruction is coming inside the process. So it will fetch the instruction. So after completely fetch the instruction in the first cycle, then only you can fetch the next cycle. So after fetching the cycle, it moves the instruction to the decoder. So in the decoder, it will decode. After decoding process is over, only it will execute. Okay. So these are the 3 processes. For example, we take there is a channel. ஒரு கோயில்னு வச்சுக்கோங்க. கோயிலில் வந்து ஒரு சின்ன பாதை இருக்கு. அந்த பாதையில் ஒரு ஆளாக தான் போக முடியும். ஸோ 3 ஸ்டேஜஸ் இருக்கு. ஸோ ஃபர்ஸ்ட் ஸ்டேஜில் வந்து நீங்கள் கடந்து போனாதான், நீங்கள் ஃபர்ஸ்ட் ஆளே கடந்து போக முடியல இந்த சின்ன பாதையிலன்னா 2வது ஆள் போக முடியாது. ஸோ ஒரு ஆள் போய் முடிஞ்சாதான் அடுத்த ஆள் போக முடியும். அதே மாதிரி தான் இங்கேயும் ஃபெச் ப்ராசஸ் முடிஞ்சாதான் அடுத்த ஃபெச் ப்ராசஸ் வந்து பண்ண முடியும். ஸோ இங்கே ஃபெச் முடிஞ்ச பிறகு தான் நீங்கள் வந்து செகண்ட் ஃபெச் இன்ஸ்ட்ரக்ஷனோட ஃபெச் இங்கே எடுக்க முடியும். Fetch process completely you have to finish. Then only you can do the next instruction fetch here, the next clock cycle. So this fetch completely finish the next fetch எடுக்கும். So fetch முடிஞ்ச பிறகு decode. இந்த decode முடிஞ்சாதான் அடுத்த இந்த சைக்கிள்ல decode எடுக்க முடியும். இந்த decode முடிஞ்சாதான் இந்த decode இங்க எடுக்க முடியும். So இதே 3 instruction. So pipelineல கொடுக்கும்போது என்ன ஆகுது? So one cycle la first instruction out of fetch முடிஞ்சிருது. Second cycle la second instruction out of fetch as well as first cycle oda decode. Third clock cycle la third instruction fetch, second cycle decode and execute first cycle oda execute completed. So fourth clock cycle la last instruction decode and second cycle oda execute completed. So fifth clock cycle la completely executed all the 3 instructions. So only 5 clock cycles are required for executing 3 instructions when you are using a 3-stage pipelining. For example, if you are increasing the number of stages of pipelining, means still the number of clock cycles will be reduced. So this is the block diagram for ARM7 pipelining. So instruction fetch is a process where you have to take the instruction from the memory. So while decoding it, it will select whether it is a normal instruction or a thumb instruction. First it will check whether it is thumb instruction or a normal instruction, and it will produce the necessary control signals. Then it will go to the execute cycle. So what are the process in the execute cycle means? It will read a data from the memory register, write a data to a memory, write work, shift the accumulator itself, shifting operations or arithmetic and logical operations. So in the 3-stage pipeline, you have fetch, decode, and execute. Fetch means instruction is fetched from memory and placed in the instruction pipeline. So decode instruction is decoder and data path control signals is prepared for the next cycle. So instruction in this stage, instruction wants the decode logic, but not the data path. So here the data path is created depending upon the instruction. So whatever instruction you have fetched from the memory will create the data path. So finally execute instruction wants the data path, the register bank is read or operand is shifted or ALU result will be generated and returned back to a particular register. These are the different operations of execution in a ARM instruction. So this is leave it. We'll take this diagram. So here we are taking 4 instructions: add, sub, compare, and add. So these 4 instructions have 3 cycles: fetch, decode, execute. So we are taking 3 instructions. Add is coming twice. Add, sub, and compare are placed in the pipeline sequentially. So after 3 instructions, once again add will come. The first cycle, core will fetch the instruction of add. The second cycle, it will decode the add instruction as well as same the fetch cycle of subtraction. The third cycle, it will execute the add instruction and it will decode the subtraction instruction and it will fetch the compare instruction. So add in the third cycle, both the sub and add instructions are moved on the pipeline. So add instruction is executed, sub instruction is decoded, as well as compare instruction is fetched. So this process is called pipelining. So when the processor is executing simple data processing instruction, these commands are very simple. Only 3 clock cycles are required, so there is no problem. But there are some instructions which have greater decoding process or greater execution time will create a problem in pipelining. We'll see what is the problem happen in this pipelining. Okay, this is the problem happen in pipeline. For example, I am taking an instruction called add. Str means store value, subtract, compare. Now, add instruction has only fetch, decode, execute. When you take the store instruction, it has fetch instruction, decode instruction. This decode instruction is not finished within a clock cycle because it has to calculate the address. So it requires one more clock cycle to calculate the address. So while calculating the address here, this in this particular time period, it is not able to decode here. The subtraction instruction is not able to decode here. It has to wait here because it is doing the decoding process. Similarly, this the add instruction also not able to fetch. Here it is not able to decode. So automatically the compare instruction is not able to fetch here. So here fetch, decode, execute, no problem. Here it is fetch, decoding. So this decoding time is more. So since this decoding time is more, so here decoding process is not able to done by the subtraction instruction. But compare fetch cycle is free. So compare is able to fetch the next instruction. Now after calculating this address, it moved to the next process called data transfer. Now it is going to the decoder cycle. This compare will go to wait for decoding because it already fetched here, but it is not able to decode it because now only the subtraction instruction is doing the decoding process. After finishing this decoding process only, it can be able to decode. So after decoding, subtraction instruction, compare instruction will decode on the next clock cycle T6. So T6 it will decode. So then a normal process will be going. So whenever a complex instruction or special instruction is doing in the ARM processing, the pipelining, there is a lag happening in this pipelining. Due to this, number of clock cycles will be increased. So this is known as hardware dependency because the decoding process a particular instruction takes longer time. Because of the instruction, it takes longer time. So it depends upon this particular decoding hardware. For example, this subtraction instruction, waiting for the decode operation to complete. So it is waiting. It is waiting for this particular hardware. So this process is called hardware dependency. If all the instructions are each similar instruction, there is no problem in the pipelining. So when you go for some instruction, it takes longer time for decoding or longer time to executing. Other processors will slow down and it wait for the hardware to release by the previous instruction. So this is known as pipelining problem based on the hardware dependency. I think comes to the end. So pipelining means what? So anyone tell? 106. Can you tell what is pipelining? 19E 106.
Sir, sir, it is a process which by which we can utilize the hardware in an efficient way, sir.
Okay. 603. 20E 603. Any doubt? Anyone having doubt means you can post or you can ask me. We see once again in the online classes detailed same topic. So here there are, even though it is pipelining, there are some drawbacks also available. Okay, it's time. You can leave the class. அடுத்த பீரியட் என்னது?